Well, now that we have a basic understanding of circular motion and simple harmonic motion as in a pendulum, we can put a couple of these ideas together into what's known as the conical pendulum. It's simply a pendulum that has a string tracing out a cone because the weight rotates in a horizontal circle. And we can show that two conical pendulums, whose weights are both the same distance from the pivot point at the top, have the same period of rotation. To do this, we'll draw a conical pendulum. So here it is, the conical pendulum. And we have a weight mg, we have tension acting on the mass in question right here. So we can see what emerges from here are two similar triangles. One triangle has the string as one of the sides, and also y, the distance from the pivot to the horizontal circle, and the radius of the circular motion itself. And the other triangle will be a force triangle with the string as the hypotenuse and the components of the hypotenuse as its sides. So let's look at the tangent of theta with the spatial diagram, opposite over adjacent. So we have r over y. And now the force triangle. In the force triangle, we have tension, and tail to tip, we have mg. The sum of those is centripetal force. And you see the similar triangle there, the tangent of theta, Fc over mg. Now the connection between these two triangles, since they're similar, the tangent of theta is the same. So r over y is Fc over mg. So we can solve for Fc, mgr over y. But we know that Fc is equal to m4 pi squared r over t squared by definition. So we're going to equate it to that, cancel out the m's and the r's, and we get from this, period squared is 4 pi squared y over g. So now we've just essentially solved for the period of a conical pendulum, 2 pi squared of y over g, which looks similar to a regular pendulum, 2 pi squared of L over g. But now instead of L, which would be like the length of the string swinging back and forth, it's the distance from the pivot to the horizontal circle, the y. Notice that it is string length independent here. Well, unless you consider that with a longer string, you're going to have a bigger r. But the point is, if you have a short string, or this string that you see here, and rotate it in this circle, if the string is longer, you could spin it faster, and the whole horizontal circle would rise up, and it would be moving around faster, but the height would be the same. As long as the height is the same, this y, then the periods are going to be the same as well. So you will be shown a very interesting example of a conical pendulum in class. Make sure to ask me about it. Don't be deprived of it. And have a great day. See you later.